Okay, well hello everyone, and welcome to today's webinar titled Working with a Multi-User Geodatabase. My name is Ian Greensmith, and I am a higher education analyst working in the Education and Research Group out of our Toronto office. For those of you who haven't attended one of our webinars before, I'm recording this session, and we'll make the recording, that's the PDF and the PDF of the slides and recording of the webinar available shortly after the webinar finishes. This webinar will provide, or it aims to provide rather, an overview of the multi-user geodatabase and where it fits in the ArcGIS platform. We'll discuss workflows that will allow you to provide access to the geodatabase by adding users and defining privileges through roles. We'll also look at some introductory aspects of versioning and replication. And overall, this session will provide, or at least I hope it will provide, clear benefits of why you should configure your enterprise geodatabase using the things that we'll discuss today for your teaching and research. Some key terms that I'll reference during the presentation today are, the first one is an enterprise geodatabase. Now, the title of this presentation is a multi-user geodatabases, and really these terms are interchangeable. The enterprise geodatabase is actually stored inside the database management system and is licensed through ArcGIS for Server Enterprise Advanced. A direct connection to a geodatabase is one that is made using the database management system's connection methods and direct connect drivers in the client application. Now, you don't need to worry so much about the back end of this stuff because a lot of it is actually, any connections that you make to a database will be made in the catalog window in ArcMap or through ArcCatalog. And if you're starting to delve into Pro, that's great. It's just that this webinar is not going to touch on Pro, but the connection workflow of connecting to a geodatabase, or an enterprise geodatabase rather, is slightly different for Pro. A role in this context is actually one that is defined by the geodatabase administrator and applied to users with very low levels of access. Users, actually I think users are pretty self-explanatory. They are the ones loading and editing data and have been assigned a role with a certain level of permissions. Geodatabase versioning, which is something I'll talk about later on, is a method by which multiple users can edit the same data without overriding each other's edits or blocking others from reading or editing the data. So this is accomplished by using separate tables for each versioned data set to track edits, as well as system tables to track different states of the data. Geodatabase replication is a data distribution method provided through ArcGIS that allows data to be distributed across two or more geodatabases by replicating all or even just a small subset of the data that you're working with. ArcGIS as a platform has a number of different components, and for those of you who have either attended a webinar like this in the past or been to one of our user conferences, you've probably seen a diagram like this. And as we start to explore the multi-user geodatabase, it'll help us to have at least a general understanding of how things fit together across the platform. Storing your data inside the geodatabase allows you to access your data across the entire platform, meaning that you're not limited to the traditional desktop applications like ArcMap or ArcCatalog that you would normally use or traditionally use to manage your data, create maps, or even perform analysis. This data can be published and made available to others via ArcGIS Server or even ArcGIS Online by the way of web mapping applications that can help extend the reach of your data to a much wider audience. These same maps can also be consumed on mobile devices like tablets and smartphones for easy access on a mobile environment. So while I'll just be focusing on the geodatabase and how it's possible to use it, it's important to just keep in mind the end use, or really the end user, if that helps. But at the end of the day, it's really we're talking about data management, and the geodatabase really forms a core in that sense. The geodatabase offers quite a bit of functionality. And just to highlight some key points on this slide here, a lot of this functionality stems, or it really includes storing of fundamental data sets such as tables for non-spatial data, feature classes for vector data, raster data sets for storing or referencing imagery or continuous data. The geodatabase also provides behavior, or ways to manage behavior rather, through rules and relationships to maintain attribute data or data integrity. It also contains tools to help maintain the integrity of spatial data by implementing advanced data sets like topology or geometric networks and even network data sets. The geodatabase can actually even store custom toolboxes. So for those of you who do quite a bit of work with Model Builder or do work with Python even, all of those tools and scripts that you create can be stored within a toolbox that are stored within the geodatabase. You can, for those of you who do geocoding and you're not leveraging ArcGIS Online to do that, if you have your own custom address locators, the address locator and the network data set can also be stored within a geodatabase. And the last point that I'll make actually ties in really well to what we're going to be talking about today. It relates to scalability and integration. A geodatabase can store and manage spatial data from the smallest project up to multiple terabytes of vector, raster, and tabular data. So in doing so, it supports a wide range of simultaneous users and editors. So let's change gears a bit, and in this first section I'm going to start by providing an overview of the multi-user geodatabase, discuss its role in the platform, and then discuss, at least at a high level, the installation and configuring process. The setup and configuration of an enterprise geodatabase starts with configuring the database management system, or DBMS client, to work with the ArcGIS platform. This involves selecting one of the supported DBMS systems that integrate with ArcGIS, and some are actually listed on screen. Not all of them, though, because there are quite a few. For the purposes of this webinar, I'm going to show you how to configure an enterprise geodatabase using PostgreSQL. But it's important to note that any of the content and workflow that I show or cover can be applied to some of the other supported database management systems. Now, to add a spatial component to PostgreSQL, you have two options, namely using the STGeometry or PostGIS to handle spatial geometries built into data formats that we're already comfortable using, like shapefiles, within the Postgre database tables. By default, enterprise geodatabases created within PostgreSQL are set to use the STGeometry data type. The PostGIS geometry data type is included with PostGIS and is actually a separate install. PostGIS follows, for those of you who don't know, PostGIS follows the Open Geospatial Consortium simple features specification for structured query language. It also uses OGC well-known binary and well-known text representations for geometry within Postgre data tables. So with the DBMS installed and the geometry type selected, we can now actually move on to creating the geodatabase. One last thing I'll actually mention here. The tool that you see on screen is one that I'll show you in the first demonstration. It's actually only available if you're using the desktop standard or advanced license, or if you've been using ArcGIS Desktop for a while, these are your ArcEditor and ArcInfo licenses. But the nice thing about tools being available like this is that they actually can be automated as well, so ranging from creating the geodatabase to adding database users, creating roles, and so on. Everything can be strung together. With the geodatabase created, we need to discuss how people are going to connect to it and what level of access we're going to be granting them. In our catalog, or even in the catalog window of ArcMap, we can generate database connections and define database roles with relative ease. To create a database connection from the folder tree, you would just double-click on the Add Database Connection icon that's there, and it's hard to see it now in the slides, but I'll be able to show you when we switch over to the demonstration. But once you double-click on it, then the image that's on screen will pop up, and then it's just a matter of selecting the database platform. So for what I'm talking about, I know I'm going to use PostgreSQL, and then I need to define the instance. So this can be installed locally. This can be installed on a virtual machine or a server. So whether you have a fully qualified name for your server or even just the IP address, that can go into the instance. Authentication type. This is where you are actually going to have to insert either your Geodatabase Administrator credentials or even the Database Administrator credentials. And as we'll talk about in later slides, that becomes straightforward. But the point of this is just to identify that you really have to select a couple of key things: the database you're going to be using, the instance you're going to connect to, at what level you're going to connect to it, and then the last one is actually choosing the database, which actually becomes a drop-down menu. So I've mentioned a few of these positions or users within the database already, but for clarity, it's really necessary to define the different types of users within a multi-user geodatabase, because they're different than what we're traditionally used to, really, if we're using a file geodatabase, or we're working with CAD data, or working with shape files, or text files for that matter. So at a high level, these include the database administrator, the geodatabase administrator, the data owner, and the data user. The database administrator, in this case because we're using PostgreSQL, is created by default when PostgreSQL is installed on the server. So the username is Postgre or Postgres. Responsibilities for this user or this role include creating the database, creating users, and creating the roles. They can grant permissions, but it's not restricted. That's not restricted to them. But they can also configure how data is stored within the geodatabase. The geodatabase administrator, or as is created when this one can be created rather when you're using the Create Enterprise Geodatabase tool, as I showed you in the previous slide. This account can be considered one of the most powerful accounts in the geodatabase, and it actually shouldn't be assigned to a single person. And what I mean by that is that by giving multiple users access to the geodatabase through this SDE or geodatabase admin role, it's a good management tactic to control for project workflow, employee turnover, or with regards to student research and student projects. Think of student graduation, vacation, and so on. The responsibilities for this user include performing maintenance tasks and managing the top level or default version of the geodatabase. The data owner. This user account is used to load data into the geodatabase. And similar to the geodatabase admin, this account is also not typically assigned to a single person, as multiple groups or departments within a school or municipal environment, or regardless of where you work, may need to be able to load data into the geodatabase. And that's really what this user level is used for. So in addition to loading data, this user can manage user permissions, fields, indexes, and even register data as versioned. and I'll talk about that in our second demonstration. And lastly, the data user. And these are the ones that make up the bulk of all of the users in the geodatabase. So whether it's Cam, Krista, Jonathan, Ian, Brent, whoever, they're all names who have been given explicit access to the geodatabase, and it's us that really are the ones doing a lot of the editing, report generating, creating maps, and so on. So with that, I just want to jump over to ArcCatalog, and or actually before I get there, I just want to show you a couple of things just to keep in mind when you want to go and set up an enterprise geodatabase, as well as configuring access for others. Now, I realize that not everybody would have access to this MyEsri portal, especially if you're a student within a university or college. But for those of you who aren't, or those of you who do actually have access to the MyEsri account, this is really a coming of age for a lot of software companies, and software is really become available to download. So this is where, if you have desktop or pro or server, for example, you would come here as the site license administrator. That is the one who controls access to the software. You would come here, access the data that we include, but we also include the software as well, and download it. So as I mentioned, enterprise geodatabases are authorized through ArcGIS for server. So I can click on this, and I can download all of the relevant packages that I need for ArcGIS server. There's even stuff related here for portal as well. But what I want to draw your attention to is stuff that's actually not on this initial page. We'll go to the additional products tab. This is where you're actually going to find the client, either database clients like Postgre. So we actually host and allow you to download the database clients for Windows and Linux for the different supported versions of Postgre. But we also do it for Microsoft, for SQL Server, Informix, and so on. And there are a number of other ones here that we host. So if you're looking to do this, this is something that you're going to have to keep in mind. You're going to need to get access, specifically if you're using SQL Server. However, if you are keen to use a PostgreSQL database with the release of 10.3, so we're at version 10.3.1 right now. At the release of 10.3, the client libraries are actually included with the install of ArcGIS server. So there's no reason, there's no need for you to download them, which is actually quite handy. So I'm just going to get that out of the way. I'm going to go to ArcCatalog. So here in ArcCatalog, or we can do the same thing in the catalog window for ArcMap. I just want to show you the tool that I've been talking about. So this is I just want to search for the Create Enterprise. Just type this in, and it'll bring up a list of tools here. But what I'll draw your attention to is this Create Enterprise Geodatabase tool. Now, to save a bit of time for any demonstrations that I'll show, I've pre-created a lot of this stuff. But you can see here that I can actually choose one of three options here. So I'll choose my Postgre geodatabase, my instance. So my multi-user geodatabases I have installed locally. So if you're going to do that, you can just type. It's actually easy to just type in localhost. But again, if it's installed on a server or on a VM somewhere, the IP address will work just fine. You'd put in the name of the geodatabase you want to provide. You would authenticate into it. So again, the database administrator, this is the person who can create the database. So you need to authenticate into that. a product of creating the geodatabase through this tool is that the geodatabase admin username and password, so SDE here, is created. And then you would you'd actually use your authorization file that you used for server to create the geodatabase. So again, I've done that, and just to save a little bit of time, because not so much in terms of creating the geodatabase, but in terms of loading data in, generating connections, and so on. But it's useful to know how to do it, and the search tool takes a lot of the guesswork out of remembering where some of these tools are. So I've got a few connection files here, and your database connections are all stored in one common area. So if you're used to searching for or creating folder connections here under your folder connections, just below that are your database connections. And to create a database connection, you just double-click on this, just as I described in the slides. Again, you choose your database, decide where it's going to go, set up your username, and choose your database, and you're off to the races. Now, as I mentioned, a lot of the stuff I created ahead of time. So what I want to do is I actually want to connect as the GIS owner. And what you'll see is that I actually have a lot of data already pre-populated this within the geodatabase. Now, because I'm the GIS owner, I have full control over this data. I also have full control over who accesses it. Now, what I've done ahead of time is I've created a planning role, and a role is created through either a geoprocessing tool, or you can actually right-click on either the SDE or the DBA connection and generate the role that way. But again, I've created the tool created the role ahead of time. But what you would do is provide that DBA or Postgre connection, type in your role, and then alternatively, or optionally rather, you can choose to assign it to a specific person. So I have, and I'll show you this when I switch over to the database client. I've created a few roles, but just for the sake of example, I'm just going to drag my my DBA connection in here. I'm just going to call this Parks, and I'll leave the username blank. And you're not going to see anything fancy, but you are going to see that it's been completed. So what this means is just like your IT group when there's a new hire, or when they're trying to configure access to certain applications that some people can have access to and some people can't. Or they do that through, or one of the mechanisms they can use to control this type of stuff is through a role. So in this case, it's the group role that I was referring to. So I've got what I want to show you next is that how we can actually in the Arc toolbox, I want to go to Data Management Tools, our Geodatabase Administration, and this is where a lot of the multi-user geodatabase tools exist. What I want to do is I actually want to create a database user. Now, I can open this tool, or alternatively, I can disconnect from here, double-click into the DBA connection, go to admin, and actually just add a user. It actually opens the exact same tool. Let's wait for my computer to wake up. Here we go. So I've got my database connection here that's already there. I'm going to actually create a database user. In this case, it's going to be Krista. I give Krista access. Going to give it a simple password that she can create later. And here, I'm actually going to assign her to a group role. So this, I'm going to assign her to planning, and then I'm going to click OK. And that goes relatively quick as well. Now what I want to do is I want to add that database connection for Krista here, just to show you how it works. So I double click on this, on the add database connection, confirm the following. But we're not working with this user. I'm actually going to connect as Krista. And this is where I can actually select any of the geodatabases that have been created and that live on the localhost instance. In this case, I'm working with the data from Kamloops, BC. I'll click OK. And you can see the connection file has been created. As a best practice, it's worthwhile to actually to rename this. So what I'll do is I'll just show you at least how I like to do it. That way, it's easy to keep track of, and that way you're not just looking at the same thing of connection. It's just broad connection files. But here, I want to show you a couple of things. The first one is, yes, it's a unique connection, and it stores Krista's information. This connection file can actually be shared as well. But because Krista is actually part of the planning role, Krista's only been assigned privileges to specific data sets. So while the GIS owner can see all of this data that's here and any relationship classes that are associated with that, if I disconnect and just clean this up a little bit, if I connect as Krista, you'll see here that that as the GIS owner, I've configured it so that the planning role can only see data that's stored within the assessment feature data set. So here we have a topology and a properties data set, and then my buildings data set. So just to reiterate, this is all controlled through roles. And just to show you what it looks like in a bit of a different environment before I switch back to the slides, I'll just show you pgadmin. This is a database client that comes installed by default with PostgreSQL. So I'll just authenticate in here. My password, and it's actually the layout's very similar to our catalog. And here I just want to draw your attention to the databases column. So here I have your Postgre database. That's one that's created by default. The enterprise geodatabases that I've created one here just for another application that I was working on, as well as this Kamloops, BC. So I can double click in here. I can review some of the items that are in here, all of the users that are have assigned schemas, but I don't really want to spend time looking at the schema here. What I want to focus on here are the group roles and the login roles. So the group roles, I created the parks role for you, but the planning role is what I used to assign Krista to as well. So and actually I can even click on this. I can find out more information about it. I can see who's actually members of this specific roles and so on. So with that, I'm just going to switch back to the slides here, and we'll move on. Okay, so in this next topic, we're going to discuss multi-user editing workflows in the geodatabase, and specifically we're going to be focusing on versioning. For those of you who attended or listened after the fact, the previous webinar that I gave, I outlined, and I apologize if this is a bit of a review for you, but I outlined really there are three common geodatabase types. The first one is a Microsoft Access-based database that we refer to as the personal geodatabase. The second one is a collection of files in a system folder that's stored on disk. We refer to that as a file geodatabase, and that actually represents an evolution from the personal geodatabase. And the third one is the enterprise or ArcGIS Geodatabase, which is a collection of tables, views, and functions stored inside a DBMS. Now, the file and personal geodatabase are most similar in that they are both designed for single user editing. However, the file geodatabase is recommended over the personal for its ability to handle larger data in terms of size and its ability to handle multiple users. It's also possible to have more than one editor at a time in the file geodatabase, provided that each user is editing a different feature data set or a standalone feature class or tables within a geodatabase. However, it really, as the title suggests on the slide, challenges arise with this editing approach. To protect the data stored in the geodatabase and help manage it, geodatabase locks are created as users interact with the database to ensure that integrity for transactions. And there are two basic types of geodatabase locks. One are feature locks. And feature locks prevent multiple users from editing the same feature and overriding one another's changes. Think of this like a Word document or Excel spreadsheet that's saved and shared on a network server that's already open and being edited by somebody else. If you try to open it, you're going to be prompted to say that so-and-so is using it. Yeah, you're going to have to wait your turn or notify them. The other one are schema locks, and schema locks maintain the consistency of the table schemas while the tables are in use. And for the purposes of this webinar, I'm just going to focus the discussion and any demonstrations I show around the versioned editing workflow. So versioning is something that's built that is accessible and possible to do only within an enterprise geodatabase. So what are versions? Multiple editors and transactions can be accommodated through an editing workflow that employs versioning. A version represents a snapshot in time of the data in a geodatabase. And that is data that is registered as versioned within the geodatabase. It's important to note that versions are not copies of the geodatabase either, but rather they're separate views of the data, while any transaction that takes place in that version that is tracked in the system tables of the geodatabase. When working with enterprise geodatabases that involve multiple users with varied roles, it's generally regarded as a best practice for users to access data through a version anyways. The version an individual accesses is predetermined by the permission level granted by the database administrator. Or as I'll show you, you can control access through yes, you can. The database administrator controls permissions, but it's ultimately the data owner who controls what data that you can actually see and what data you can actually get to. So when data is registered as versioned, two tables or two delta tables are created: A for adds and D for deletes, and they're created to track insert, update, and delete operations performed on the data. So really, in a version data set, it actually consists of the original table plus any changes made by each user. They're stored in those delta tables. A typical workflow for setting up versioning or consolidating edits across versions and maintenance in the geodatabase can look like what you see on screen. If you work your way from left to right, you really start by registering the data as versioned. Now, I'm not sure if that sunk in the previous slide, but that's really a key component. The entire geodatabase can be registered as versioned, but more often than not, you don't need access to the entire geodatabase. You just really need access to, let's say for the sake of example, 2 or 3 data sets, or feature classes rather, that are stored within it. So long as those 2 or 3 feature classes are registered as versioned, you can have access to those and solely work within those. So that's the first thing you do. You register the data as versioned. And that's typically done by the data owner. The next thing you do is that you create a new version. Once the data is registered as a version, or a new child version can be created that branches off of the parent. So I'll refer to this notion of parent and child. It actually helps to keep it as opposed to origin and destination, for example. But when created, this version is identical to the parent, but over time, and any version that actually branches off of that child will change. The middle one, this third or purple box, this is really something that we're already comfortable with. So this is identical to non-versioned editing. So it's something that you edit shapefiles or traditional personal or file geodatabases. You can, the editing workflow is identical in this sense. But once you are done your edits, the next thing you need to do is you need to reconcile your edits. So that is reconciling edits that you make in the child back to the parent. So the parent is what you branched off of. So the term is called reconciling and posting. So reconciling and posting changes integrates your edits into the parent version. When you reconcile, all edits in the child version, so what you've branched off and used, are compared to that of the parent version. And that's what you actually want to merge them back into. If there are any conflicts, those conflicts are flagged for review. Now, conflicts can come up. They're beyond the scope of what we're going to be talking about today, but for the most part, if you are the only editor and depending on your reconcile and posting workflow, you won't run into conflicts. Conflicts typically arise when there are multiple child versions that are being reconciled back to one parent, and edits have been made on similar features. The last step here relates to analyzing and compressing a geodatabase. So this is something that you may see the option when you're working with geodatabases, or for the file geodatabase, for example, but really this helps improve the performance of the geodatabase. So as child edits get posted to the parent version rather, over time it can be beneficial for the child version to compress the geodatabase and ultimately speed up the performance. What you're doing by compressing it is you're removing all of the states. So each time you add a feature, you add something to attributes that adds a state in the state lineage of your versioning tree. Compression removes that, and once you've posted your changes, you can actually get rid of your version altogether because it's all being consolidated and posted back to the parent and move on. The last step that I mentioned is analyze. So whenever you're working, especially with an enterprise geodatabase, in terms of indexing, it's important to have up-to-date database statistics. And each time it's run, it just helps the software reference up-to-date statistics that can help really improve the geodatabase performance. So there's a lot to really digest here on the slide, but it really starts by registering the data as versioned, creating the version, going through a simple editing workflow, reconciling and posting your edits, and then really compressing and analyzing the geodatabase to help improve performance and speed up indexing. So why use versioning? What are some of the reasons why you would use this workflow? So let's say, for the sake of example, that I work in the planning department for a municipal government where we have parcels for the municipality that are available online for the public to see. However, the department I work in receives daily applications for subdivision development. With versioning, it's possible for the public to view the official parcels while another version exists for the planners to work with. Versioning can also be useful to model what-if scenarios, such as flooding. A separate version in this context would allow individuals to work with the same data to perform analysis that cannot be seen by other versions until the project is official. Versioning also lends itself to allow for multiple stages of the project, such as to keep track of multiple stages of projects such as roads over a given period of time. Be able to determine what roads are different by specific versions created in specific years. Another way to look at that specific example is to incorporate geodatabase, is to incorporate archiving, but that's really beyond the scope of this webinar. But what I want to do is I want to switch back to ArcMap now, and I want to show you a little bit of versioning before we move on to our last topic. Okay, so we're here in ArcMap, and in the catalog tree, I have my database connections here. And what I want to do is I'm just going to refresh them because I want to bring in that Krista connection here. And you'll notice that if I actually go into the Krista connection here and access the data, if I right-click on it, there's interesting content that comes up in the context menu. Now, because I'm just a data user, I don't have access to a lot of this information, so a lot of it's grayed out. But if I actually if I disconnect from this user and I connect as the GIS owner, I will be able to see there's quite a bit of information available to me. Specifically, what I want to draw your attention to is this option that's grayed out. So I remember one of the first steps is to register the data that you want to work with in a specific version as versioned. So I've gone ahead and done that. And I've done that specifically for the properties data set, and I've also done this for a buildings data set. So you see that as grayed out. I also have the option to unregister it. I also can restrict who has access to this. So I talked earlier about that. Here I have a couple of roles. One, my planning role. So this is where Cam and Krista can actually access specific data sets. And I also have a GIS group role as well. But I'll disconnect from the GIS one and I'll reconnect to Krista. I'm going to add this data in. I'll just let it come in. I'm just clean up the drawing order a bit, and I'm going to go back to the source tab. So here I've connected. I have a database connection as Krista, but look at what I want to draw your attention to is here in the source. So here I have my default. So this really is the highest point of the versioning tree. This is there is nothing about this. This is kind of your state 0, if you will. But what I can do is I can go in and I can either change versions or I can create a new version. And as I mentioned, to save a little bit of time, I've created some versions ahead of time, and you can see who owns them as well. And that's really something that's quite useful in the geodatabase administration side. So you can see here that the default version is owned by STE. The GIS owner that I've been doing a lot of I showed you a lot of stuff with that. We've created a number of versions here, and then our STE Geodatabase Administrator has created a publication version as well. But what I want to show you here is how we can connect to this specific version. And you'll see here that now it says who owns the version and then the name of the version, and it's still tied to the instance. But what I'll do here is I just have a quick bookmark here. And what I want to show you is that I can start an edit session. Now I'm editing. And what I want to do is just, within this version, let's say for the sake of example, we've received instructions that these two selected parcels are to be merged. So what I'll do is I'll just select those two, and then from the editor toolbar, select merge. I'm going to be prompted on which partial it should be merged into. I'm going to merge it into the one on the bottom. That's P62824. I'm going to click OK. And then I'll clear my selection. Now what I'm going to do is I'm going to go to my my versioning toolbar, and it's docked up here in ArcMap here. But here, this is where I can actually review any versions that have been created. So just like I was showing you earlier, if I wanted to create a new version, I could create a new version using this. But what I'd like to do is I want to reconcile my edits. So that's reconciling my edits back from the back into the parent of the staff version, which happens to be the planning version. So what I'm going to do is I'm just going to click reconcile. It's going to ask me how do I want to handle reconciling the changes that I've made. Specifically, I want to reconcile in favor of the target. So that's in favor of the child, really, that I'm working with. So I'll click OK. So what that does is it compares what is in the child to what is in the parent, and once that's gone through and no conflicts have been detected, then this icon here will be visible, and that's post your changes. And it's as simple as that. Now, if I were to switch versions out into the planning version, I'd see that this change has been made. As I mentioned before, I'm not going to be touching on conflicts, but in general, conflicts can be detected when you reconcile with a target version under the following instances. So the same feature is updated in both the current version being edited and the target version. The same feature is updated in one version and then deleted in another. Or even if you're working with advanced data types like topologies, so a topologically related feature or even a relationship class is modified in a current version being edited and the target version. So conflicts really can become quite complex, but the concept of registering your data as versioned, doing your edits, reconciling your edits, and posting your changes, that is actually quite straightforward. And that's really what I wanted to get at in this second demonstration. We'll just save my edits, and then I'll minimize this, and we'll get back to our slides for the last part. So as we discussed in the previous section, the efficient management of an enterprise geodatabase that is accessed by multiple users with read-write access is greatly assisted through the use of versioning. In this last section, I'm going to try to build on the concept of versioning by discussing a form of data distribution that's termed geodatabase replication, and demonstrate how through a replica you can manage a workflow of distributing data to users outside of your organization, or even outside of your school or outside of your network. So geodatabase replication is the data distribution method used to share enterprise-level data within the ArcGIS platform. It's built on top of versioning. So data needs to be registered as versioned in order for this to work. Replication supports the full geodatabase model as well, so that includes topology, networks, and behavior rules, and relationship classes as well. This distribution method, it uses an asynchronous model where any data conflicts are resolved prior to committing changes back to the parent replica. This replication type is also loosely coupled, which means that a replicated geodatabase can work independently from its parent, and any edits can still be synchronized. Similar to registering a database as versioned, when all or part of a version of a dataset are replicated, a replica pair is created. One replica resides in the original geodatabase, that is the parent, and the related replica is distributed to different geodatabases. in this case, child or multiple children. Depending on the replication workflow chosen, it's possible for any changes made to the replicas in their respective geodatabases to be synchronized so that the data in one replica matches that in the related replica. It's important to note that, I feel like I'm a broken record sometimes, but it's important to note that the data really does need to be versioned in order for this to work. So if you're trying to go down the replication path and you can't figure out why icons aren't showing up in the distributed database toolbar, for example, that's because a lot of this stuff is tied to not being registered as versioned. In addition to that, your data must have global IDs. Now, depending on the data model you're using, like if you're using the Canadian Municipal Data Model, for example, global IDs are built into the data model. So every data set that is imported, a global ID will be assigned to it. It's not really anything you need to worry about because either the data model is going to take care of it for you, or you can actually manually add global IDs, and I can show you how to do that. There are a number of different scenarios of where replication can be useful, and that I'll include that link to you when I send out the slides and the recording. But in terms of replication types, there are different options to consider on how you want to replicate your data. They can all be done either in a connected or disconnected environment, and all of them, as each one, require the parent, at least the parent, to be an enterprise SD geodatabase. The first option is check-in, check-out. This allows you to edit data in the child replica and synchronize these edits back to a parent. Replication, in this case, only occurs once, and when the edits are synced back to the parent, then the replica is discarded. Think of it like a temporary connection, or even this phone call. I'm transmitting information to you over the phone. As soon as I hang up the phone, there's no more connection. Check in, check out. The second option is one-way replication. That's the one I'm going to show you. And this is ideal if you have a scenario where you have a production and a publication geodatabase. The one-way replica will allow you to send the edits multiple times, which is a big advantage over the check-in, check-out method, to the other geodatabases and allow users connected to those geodatabases to use them. The one-way child replica is considered read-only, and that's really one downside, is that you can't sync it back. So you can't make changes to the child and push them back to the parent. But that's really the argument for using the last type of replication. And really it's the most powerful, since you can make edits to either side. So that's the child or the parent geodatabase multiple times and synchronize the changes back and forth between them. And this is called two-way replication. It is useful in situations where multiple editors are located in different offices. Those changes can be sent from satellite offices, for example, back to head office and vice versa, all using the exact same replica. The hook with this one, this last replication type, is that both geodatabases have to be ArcSDE or enterprise geodatabases for it to work. So with that, in the time that I have left, let's jump back over here. I've got two MXDs here, open, one representing my parent replica, if you will, and the other one representing my child. And what I want to show you is not so much how the replicas are created. That's actually quite easy and quite straightforward to do just through the distributed database toolbar here. And a lot of that becomes unlocked as soon as data becomes versioned. But what I want to show you is the source. So here I'm in my parent MXD, and I have my buildings and my property, and I'm just zoomed in on an area of interest. Here I have the version. I actually tried to draw your attention to this earlier. So this is The version is called publication, and it's owned by the geodatabase administrator. So that's the parent. On the other side, I have the child. The child is actually just a file geodatabase that's stored somewhere on disk. So for the sake of example, what I want to show you is how using a one-way replication workflow, users who have access to the production geodatabase, that is the enterprise geodatabase, can load data and then sync that data with satellite offices or contractors or people just working off the network. And to do that, I'm just going to go back to one of the first tools I introduced you to, and that's the append tool. I introduced it to you in the previous webinar. So my input data set here, I'm just going to browse to it. I just have a building shape file here. Click Add. My target data set is actually my buildings data set that's already inside the map. For those of you who are familiar with using the append tool, you have the option to force it to check the schema. In this case, I know that the data that's being appended, the schema already matches, so I'm not going to bother testing it. And then I'm just going to click OK. The tool's going to run. The data is going to be added into the map in the designated area. Now what I can do is once that data has been added, and I'm not in an edit session either, once that data has been added, I can actually go here to my distributed database toolbar, and I can synchronize my changes. So again, I'm working with an enterprise geodatabase on the left-hand side, and I'm going to push these changes. I'm going to sync these changes to the replica that lives within a file geodatabase. And this is just done by clicking on synchronizing changes. You can select, just accept the defaults here, click Finish. I'll refresh my screen. And here you can see that data from the replicated geodatabase, the enterprise geodatabase, has been pushed to the file geodatabase. And that's really what I wanted to show you. But you remember that this is one way. If I had configured an SDE geodatabase, or enterprise geodatabase rather, on the other side, I could have appended this data, pushed it out to the other one, made an edit, for example, whether it's to a building or to a parcel, and push that back, and everybody would have been able to see it. But conceptually, that is geodatabase replication. So with that, we'll switch back to our slides, and let's wrap things up. So in summary, I've gone a little bit longer than I wanted to, but in summary, at least what we've covered over the last hour, we learned about some of the fundamental aspects of the multi-user geodatabase. And I think there are a lot of key points here. First, we looked at where the multi-user database fits in the ArcGIS platform. We looked at creating an enterprise geodatabase and configuring access through database users, roles, and connection files. And finally, we looked at version editing workflows and data distribution methods for geodatabase replication. If you want more information on this, a really good starting point is actually available right online in what used to be the ArcGIS Resource Center is now kind of been divided up. But the links here you'll have when I send out the slides. The first one gives a really good tour of the geodatabase. There's also file geodatabase tutorials. And the second one actually touches on a lot of key aspects of the enterprise geodatabase, or working with an enterprise geodatabase, but in this case you're not working with a full enterprise geodatabase, you're going to be working with SQL Server Express. But versioning can still be done with it, and archiving can still be done with it, and so can replication. So there's a lot, or replication can be incorporated with this. So a lot that can be done with these two links. For something that's a little bit more homegrown, some Canadian examples, I really invite you to check out our lesson planner. And if you weren't already aware, you'll find a wide range of learning resources that really relate to what we've discussed today. Whether you're looking for desktop, online, or solution-focused resources, you can use the tool that's available through the link on screen to quickly search and find what you're looking for. A relevant example of this are the Geodatabase labs that I created last year, actually, that cover quite a bit of the material that I covered today. Now, those were created for 10.2.2. So that some stuff has changed a little bit, but a lot of the core concepts still apply. And what's really great about this lab series is that it uses the Canadian Municipal Data Model that I mentioned earlier and focuses on file geodatabases as well as enterprise geodatabases. So on behalf of Esri Canada, I want to thank you all for attending this webinar. Please feel free to contact me at any time. My email is there on screen, and I'll make the slides and recording available shortly after the presentation finishes. So thanks, everybody.